Hi guys, welcome to NEET World of Physics. So in today's class we are going to start with the module 8 of vectors and scalar topic. Okay, so in yesterday's class we have discussed about, in last video we have discussed about the scalars and vector. Like scalar is nothing but it has only magnitude, whereas vectors has both magnitude as well as direction. Right. Yeah, so scalar has only magnitude, whereas vector both magnitude as well as direction. Right, this is what we have discussed about in last video. So today's class we are discussing about what is a component of a vector. So we can say vector which is nothing but a magnitude and direction, but in another words we can represent, that is components of a vector. A vector can be represented in terms of magnitude as well as direction. This is the first point we have seen about the vector, but we can represent in other terms, that is component. So which is nothing but change in x and change in y, we will say. So any vector can be broken down into parts along the coordinate axis. Either it can be x or it can be y, right. The fourth point is these parts are called components. So first thing, any vector can be said to be as magnitude and direction. In another terms, it can be represented in terms of change in x and change in y, where these change in x and change in y called as components. So component helps simplify the vector calculation. So we will see how to take the components. Right. So let me take x and y axis. So this is y axis and this is x axis. Right. So there is a vector A. Vector A. In x axis and y axis I should take the components, right. This is the angle which is made by them with respect to x axis. So we know that this is the component, no, this is component of, that is ay, I will say, and this is the component. Let me write, take in red color. So this is ax, is this visible, or let me use the another color, that is yellow. Yeah, this is ay and this is ax, right. So I can write that cos theta. What is cos theta? It is adjacent by hypotenuse, right. Adjacent, what is adjacent here? Ax. So ax divided by hypotenuse is, that is modulus of a, that is magnitude of a, we will say. So mod a. So I can write this one in terms of ax is equals to magnitude of a into cos theta, right. Then sin theta, what is sin theta? We know that it is opposite by hypotenuse, right. Opposite, that is ay by mod magnitude of a, which is nothing but ay is equals to mod a sin theta. Understood? Like this is how we will take the components for the vectors, that is ay and ax, right. Simple thing, like whenever there is a vector, an angle is made either in x axis or y axis. Let me consider for the x axis now. One more thing is there. So a vector is there which makes an angle with respect to y axis. This is y and this is x, right. Now the angle subtended or with respect to x axis, no. So where it's subtended with respect to is said to be cos theta, right. This x axis cos theta, this will be sin theta. Now if I see this one, no, it is correspondent to y axis, no. Now this will be cos theta and this is sin theta. So one will be cos theta, the opposite one will be sin theta. So in this thing, angle is with respect to x axis, So this one ax will be cos theta, ay will be sin theta. That is what we have got here, right? So ax is equals to a cos theta, ay is equals to a sin theta, right? So if I take this example, no, I will get ax is equals to a sin theta, right? Then ay is equals to a cos theta. So see the angle where it has been made, then take the components accordingly. So now position vector, the next topic is position vector. So to locate the position of a given point in a space, so space in the sense, if I take x axis or y axis or z axis, if I take any point, that point is said to be the point is in space, we'll say, right? So or a plane, generally a fixed point of a reference called origin. So with respect to origin, we'll take a reference. Okay, so origin is my reference point. With respect to origin, I will take the position vector. So for a point, there is only one position vector. So if I consider any point, so only one position vector will be there. So with respect to the origin, right? So it changes when position of origin changes. So if origin position changes, position vector also will be changed. So if I take this is my y axis and this is my x axis. So this is my origin, right? I will name it as O, which is 0, 0, right? If I take a vector P, so the position vector I will denote it as R. So this is my position vector. So how I can write, this is my x comma y, the point x comma y, any point like 2 comma 3 or 3 comma 2, whatever the point you can take it. So how I can represent OP, that is OP is equals to our position vector, I can say position vector is equals to xi cap plus yj cap. Yeah, yesterday we have, like in the last video we have seen, no, x axis, y axis, z axis represented in terms of I cap, j cap and k cap. So xi cap plus yj cap. If in case this is the point given x comma y comma z, right, then what will be my position vector? So O, this is I will consider as A, for example. So OA will be is equals to R, so xi cap plus yj cap plus zk cap or zk cap. So this is how we will write the position vectors. So next one is displacement vector, which is denoted by the symbol S or letter S. Okay, it is a vector that represents the change in object's position. So when there is a position, no, if the position is changed, I can say it's displaced from one place to another. For example, so this is my x axis and this is my y axis. So let me consider this is a vector A and this is a vector B, right? So this is my origin, right, O. So let me take, this is position vector RA, position vector RB. If I need to find what is the change in position, that is displacement vector. So let me take, this is my displacement vector, yes. Okay, so which is nothing but AB, no, AB is my displacement vector. So AB is equals to, or I can say it's a yes displacement vector, which is equals to OB minus OA, OB minus OA, where I can take this point as x1 comma y1 and this point as x2 comma y2, right? So OB, so this one will be my y2 j cap, right, y2 j cap, or I can say like totally, yeah, x2 minus x1 I cap, right, plus y2 minus y1 j cap. Understood? So when there is a change in position vector, I will say it is a displacement vector. So this is how I will denote it, like the symbol S or the letter S. So where x2 minus x1 I cap plus y2 minus y1 j cap is my position vector. So in terms of x, y, z is there. So x2 minus x1, y2 minus y1, z2 minus z1 will be my position vector, right? So there is a question now where a force is given, force as a magnitude of 15 Newton. So they have given that magnitude of 15 Newton, direction of F, that is force, is 37 degree from negative x-axis. So negative x-axis means like x-axis towards the positive y-axis. So from negative x-axis towards the positive y-axis. So if I take the graph now, this is how it will be, right? So this is my plus y, this is my minus y plus x, and this is my minus x. So what they have said, F is 37 degree, so it makes 37 degree whatever. Now what they are saying, from negative x-axis. So from negative x-axis making 37 degree towards the positive. So this is my positive now. So either if this point is not there, okay, only this point is there from negative x-axis, either it can be like this or it can be like this, but they have said that it is positive y-axis. So I can draw like this, no? So this is my F, which is equals to 15 degree. So 15 Newton. So represent F in terms of I cap and j cap, I cap and j cap, right? So if I take the components now, I can easily represent that, right? If I take the components, how I can take, this is angle is given with respect to x-axis, then x will be my cos theta, so y will be my sin theta. If angle is given with respect to y, y will be my cos theta, x will be my sin theta, right? So can you do it? Yeah, do and tell. So whoever watching now, you can give answer in the comment boxes. Yes. See, listen, if I take the components for this one, no, so fx will be my f, x will be is equals to f cos theta. So where f is nothing but 15 Newton, so 15 into cos 37 degree, so cos 37 degree, right? So we have seen how to find cos 37, sin 37, cos 53, sin 53, right, by using 3, 4, 5 method. Like how I can use, see, this is my 53, this is my 90, and this will be my obviously 37 degree. So take the 5 with respect to hypotenuse. So remaining number is 3, no? So keep the 3 here. So 3, 4, 5. 4 will be my other side. Now cos 37, right, adjacent by hypotenuse. So 15 adjacent, that is 4, hypotenuse is 5. Understood? So 1 sir, this is 3 sir. So what will be my answer? This is 12. So 12 I cap, which is the symbol, either it is positive or negative. It is negative because it is in the negative x-axis. So minus 12 I cap. Now Fy will be equals to F sin theta, right? What is F here? It is 15 Newton again. So 15 sin 37. What is sin 37? Opposite by hypotenuse, right? Opposite is 3, hypotenuse is 5. So 15 into 3 by 5, which is nothing but 3 will get cancelled. Sorry, 5 3s are 15, so it will get cancelled. So 3 3s are 9. So it is 9 j cap. It is positive. It is in the positive y axis. Now I can represent. So F will be equals to fx plus fy, where minus 12 I cap plus 9 j cap is my answer. So this is how you will represent when a magnitude of a given vector is given. Okay, magnitude of a given vector is provided, and if I want to take any component, so this is how I will write, either in x axis or y axis. So I will write it. Understood? So f will be equals to minus 12 I cap plus 9 j cap. So we will go for next. Find the magnitude and direction of a vector A. So it is 6 I cap minus 8 j cap. So try this problem and give me answer. Yeah, you can give answer in the comment boxes, guys. So it is 6 I cap minus 8 j cap. So I need to find the magnitude. So when I want to find the magnitude, what is the formula? It is under root of 6 square plus minus 8 square, right? Yeah, correct. So if I want to find the magnitude, so modulus of A will be equals to under root of, what is that, 6 square plus minus 8 square. So when I square minus, now it will become plus, right? So what is 6 square? It is 36, 8 square is 64. So under root 100 will be 10. So it is 10 units, right? Now if I want to find the direction now, magnitude completed, what about the direction? Okay, take the graph. So 6 I cap given, no, 6 I cap in the sense it is positive x axis, minus 8 j cap, so minus j, it is negative y axis, so it mostly it will be in this direction, positive x axis, negative y axis. If I want to find the angle, no, so angle tan theta will be equals to y by x, simply we can write y by x. So what is y? 8 by x is 6, so which is nothing but 4 by 3. So theta will be equals to tan inverse of 4 by 3. By using 3, 4, 5 angle method, I can find it, the angles here. Okay, this is how you will find magnitude as well as direction. Next one, product of a two vectors. So before we have seen product of a vector by a scalar, now product of a two vectors. So first point, in a vector algebra we combine vector using products. So those products, like I can say it is a dot product, first one, or I can say it's a scalar product. Second one is a cross product or a vector product. So either I can say it's a scalar product or a dot product or vector product or cross product. First one dot or scalar, second one cross or vector. Third point is this helps in determining work done, torque and other physical quantities which are coming in the upcoming classes. So these products are useful in the upcoming classes of the physics, right? We will see how to use this. So dot product, first one, or a scalar product. Dot product is a way of multiplying two vectors that result in a scalar. So when I take two vectors, no, if I multiply the two vectors, I will get a resultant scalar, not as a vector, I will get a resultant scalar, that is said to be a dot product or a scalar product. So that is a number without direction, so only number, there is no direction for that, it is a scalar product, no, I mean it is a scalar resultant, no, vector product of a scalar resultant will get, so there is no direction, only the number will be there. So if A and B are two vectors and theta is the angle made between them, then there is dot product is given by A dot B is equals to AB cos theta. So this is the formula. A dot B is equals to, like A vector dot B vector is equals to AB cos theta, right? Now algebraic form. One more thing, like for the dot products, I dot I is equals to 1, J dot J is equals to 1, K dot K is equals to 1. Okay, Now if I take I dot j, which is 0, j dot k is equals to 0, k dot I is equals to 0. This is the condition you should know when you are doing the dot product or a scalar product. I dot I is equals to 1, j dot j is equals to 1, k dot k is equals to 1. I j 0, j k 0, k I 0. So now come to the algebraic form. That's what we have discussed here in I j k form. Suppose there is a vector A is equals to a1 I cap plus a2 j cap plus a3 k cap. B is equals to b1 I cap plus b2 j cap plus b3 k cap, where a dot b, so a dot b, a vector dot b vector is equals to, when I take a1 I cap with respect to, I need to multiply with b, total b, right. So if I multiply a1 I b1 I, I'll get a1 b1 I dot I, it is 1, right, plus a1 I b2 j, I and j is 0, no, so then a1 and b2 will be 0 plus 0, again if I multiply this one also, like a1 I plus b3 k, again 0, I dot k is 0, no, so 0, so I can write directly here. So a1 b1 plus, now a2 j is there, if I multiply with I 0, with j I will get a2 b2 plus, if I take a3 k, if I multiply with or dot product with b1 I plus b2 j plus b3 k, what I will get? First k I will be 0, k j also will be 0, but k dot k will be 1, so a3 b3. So this is my dot product of a given vector, that is a1 b plus b, a1 b1 plus a2 b2 plus a3 b3. Okay. Now, so properties of the dot product. First one, commutative property. So a dot b is equals to b dot a. So we have seen like I dot j or previous case, yeah. In this case k dot I we have seen or k dot j we have seen. Here I have written j dot k no is equals to 0, or in case of I can write k dot j also, both are equal only, that is what they have discussed here. So a dot b is equals to b dot a. Distributive property. So a dot of b plus c, which is nothing but if I take the dot product multiply with this, so a dot b plus a dot c. Scalar output. So result is a scalar, it is not a vector, that is what we have discussed. So perpendicular vector. So when I talk about the perpendicular vector, no, what is cos 90? Cos 90 is 0, so I will get 0, understood. So when I talk about the perpendicular vector for a scalar, scalar product or a dot product, the answer will be 0. Next, parallel vector. So parallel vector means theta is equals to 0 degree, right. So it is a maximum value. When I take anti-parallel, no, cos 180 is minus 1, right, that is the minimum value you can say. So this is my properties. Now applications where I can use, like where we are going to use work, power and electric flux, where work is equals to F dot D, power is equals to F dot V, that is force into velocity, force into displacement. Work is done only by the component of force in the direction of displacement. Power is the rate of work involving in direction of force and velocity, where electric flux. So phi is equals to E dot A, electric field through a surface area. So this is electric field and this is area, right. Next one, example. These are the example. So try this example and give me answer now. Yes. Yeah, you can give answer in the comment boxes, guys, for these questions. Yeah, give answer for these three questions. If A is equals to 6, B is equals to 8, angle between them is 90 degree, A is equals to 5, B is 7, angle is 60 degree, and A is given as 3i plus 4j and B is given as I plus 2j. So I can use both formulas which we have discussed, algebraic formula as well as the direct formula, AB cos theta, right? Yeah, you can use this formula and you can give the answers. Okay, we will write the answers now. Fine. So first one, A is equals to 6, B is equals to 8, angle is 90 degree. So A dot B, A vector dot B vector is equals to AB cos theta. AB cos theta, right? So what is A? 6, B is 8, cos 90, 0. So total answer will be my 0, right? Next one, B, A dot B is equals to AB cos theta, where A is 5, B is 7, right? B is 7, cos 60, it is 1 by 2, right? So 5 sevens are 35, 37 divided by 2, 17.5 is my answer, right? This is my answer. Now if we talk about in like A is equals to 3i plus 4j, B is equals to 2i plus 2j, I mean I plus 2j. So for these kind of things, A dot B is equals to, first take I cap multiply with total B, that is I plus 2j. Next take j cap 4j cap and multiply with B, or else I can do take I cap and multiply with A, take 2j cap and multiply with A, both are correct. Like we have seen the properties, no, commutative property, A dot B is equals to B dot A, it's applicable. So 3i into I, that is dot I, so I will get 3i 2j 0 plus 0. Now 4j I will get again 0, 4j plus 2j, I mean 4j dot 2j, that is 8, I will get answer as 11. This is my answer. Okay, 3 plus 8 is 11, right? So this is how you will do the dot product or a cross, I mean dot product or a scalar product. Next one, a vector product. So this is a cross product, it's not a dot product, it's a cross product. Okay, so cross product of a two vector is a vector perpendicular to both of the given vectors. So whenever we take a vector as a cross product, no, the resultant will be my vector only. When I take a vector with a scalar product, it is a scalar, or a dot product, it will be a scalar, right? So here I have taken a cross product, so the resultant will be my vector. If A and B are two vectors and theta is the angle between them, then their cross product is given by A cross B is equals to AB sin theta, whereas there AB cos theta. So remember the formula whenever you are doing the problem, A dot B is equals to AB cos theta, A cross B is equals to AB sin theta. Now right hand thumb rule. So one more thing, like how the resultant vector is coming. If I take vector A and vector B. Now if I take here, no, like A cross B, from A to B I am taking A cross B. So to determine the direction of A cross B, point your finger along A, curl them towards B. Your thumb shows the direction of the resultant. So if I take, this is my initial vector to the final vector. So my resultant vector is outward, that is like this, it will come outward. When I take, so for this one it is outward. So if I consider B is my initial vector and A is my final vector, so this is my initial vector, so coming towards A, so my thumb is showing the direction inside, so it is inward, outward and inward. So listen carefully, whenever you are using a cross product, okay, or a vector product, take the first vector, curl towards the second vector, your thumb gives the direction of the resultant vector. So A vector towards B, my thumb shows the direction of the resultant vector, that is outward. When I take the first vector as B and curl towards the second vector, that is A, my thumb shows the direction of the resultant vector, that is inward. Understood? This is how you will use the right hand rule here. Now the properties. So non-commutative property, yeah, we have discussed now right hand rule. So when I am coming from A to B, it is outward. When I come from B to A, it is inward. So it's non-commutative property, it's not applicable. So A cross B is not equal to B cross A, that is minus, I will say, that is opposite direction, no. So I have written here minus B cross A. Distributive property over addition, that is A cross B plus C, that is A cross B plus A cross C. So it's not associative property also. A cross of B cross C is not equal to A cross of B cross C. So it is not an associative property. Now A cross A, we know that like whenever I take a parallel vector, no, it's A vector, again it's a vector, angle between them is 0 degree. What is sine 0? It is 0, right? So simply we can say any vector cross itself is a 0 vector. Understood? Now concepts where we are using the vectors, I mean vector product, torque, angular momentum, magnetic force, area vector, where torque is nothing but R cross F. So torque is a perpendicular to R and F. Okay. Next, L is equals to R cross P. Direction of L is perpendicular to the motion. Okay. So it's angular momentum. So magnetic force. So F is equals to QV cross B. Force on moving charge in magnetic field. Area vector, parallelogram area. Okay. So in this concept we will use the vector products. Right. So there is some examples here. So first example I will do. Try to give the answer for the second one and third one. So if I take A is equals to 2I plus 3J plus K and B is equals to I minus J plus 4K. Simple thing, take a modulus or determination, you know, like determine matrices and determinants. So I cap, J cap, K cap. So write the given 2, 3, 1. This one is 1 minus 1, 4. So if I want to find the cross product, so first keep I. So plus minus plus. So plus minus plus. This is plus minus J plus K. So when I want to find I, no, close this one and this one. If I want to find I, close this thing and this thing. Okay. So cross multiply, 3 4s are 12 minus 1 into 1 minus 1. So minus of minus 1. Understood? This is how you will do. Close this one and cross multiply. When you are multiplying this one and you should minus this thing. 3 4s are 12 minus of minus 1. Now if you are finding for J, no, close this thing. 2 4s are 8 minus 1 1. 1, so 1 as it is. Now for K, close this thing. Okay, close this. So for K, you are closing this thing. So multiply this. 2 into minus 1 is minus 2. Now 1 into 3 is 3, that is minus 3. So answer will be my 12, minus of minus will be plus, that is 13 I cap. Now minus, that is 8 minus 1, 7. So minus 7 J cap. Now minus 5, no, minus 2, minus 5, minus 3. It will be minus 5. So minus of plus will be minus. So minus 5 K cap. So this is the answer for my first question. Understood? For the second question and third question, give answer na? Yes, you can try and give the answer. Yeah, easily we can say like angle is 90 degree. So sin 90 is 1. So A cross B is equals to AB sin theta. So what is A? It is 3 I cap, 4 J cap. No. So I I cross j. One more thing is like I cross I will be 0, j cross j will be 0, k cross k will be 0. Okay, and a trick is there to follow here. I is there, I, j, k. So when you cross multiply, that is cross product I cross j, the resultant will be my k. That is perpendicular. No, resultant is always perpendicular, we have discussed. So j cross k will be I, k cross I will be j. If I go in the reverse manner, the negative symbol I should have. Like I will write here, I cross j will be k, j cross k will be I, k cross I will be j. Understood? So if I go in the reverse manner, that is, see, I to k, I cross k, it is minus j. So if I take and if I keep in the reverse manner, no, it will be minus. That's what the property says. See, a cross b is equals to minus of b cross a. So if I write k cross j is equals to minus I cap, j cross I cap is equals to minus k cap. This is the formula you should keep in mind. A simple trick, I j k, I to j resultant will be k, j to k resultant will be I, k to j, I mean k to I resultant will be my j. If I take in the reverse manner, add negative symbol to that. That's it. So I cross j is k, no, so k cap 3 4 4s are 12, so sin 90 is 1, so 12 k cap is my answer. Now third question. So third question, given that f is equals to 5i plus 2j and position vector r is equals to 2i plus 3j plus k. So here k is not given. What should I do? So simply add 0. So if I add 0, no, again the same answer will be there, right? So f is equals to 5i cap plus 2j cap plus 0k cap. Understood? Either I can neglect this or I can write like this also. R is equals to, what is R given? 2i cap plus 3j cap plus k cap. If I want to find what is f cross r, so take modulus I j k, so plus minus plus, plus minus plus, right? Now what is the given numericals here? 5 2 0, again 2 3 1. So when I want to find I, close this one. If I want to find I, close I and this one, cross multiply, right? If I want to find j, close this one, cross multiply. If I want to find k, close this one and cross multiply it, you will get the answer, right? So this is the way to find the vector product or a cross product. So this is about cross product, vector product, and then we have seen about a position vector, displacement vector and components of the vector. So total we have completed vectors and scalar basics. Okay. So in next class we will see some more bridge course modules, right? Okay. Up to that, thank you guys. Yeah. So if you are having any doubts now, you can give comments, comment in the comment boxes, I will reply for that, okay? I will clarify your doubts. Thank you guys.